Good afternoon. Today my topic is numerical problems on optics. I am Shelly Singla from GPC Khuni Majra. First of all, to start the topic, we will discuss a few formulae based on the numericals. Formula in which numericals are based. The first formula is of refractive index. The refractive index of any material is denoted by mu. This is equal to the velocity of light in medium, which is in vacuum, which is c, divided by velocity of light in medium, which is v. So this is the first formula. Second formula is of refraction. In this formula, the ratio of sin I to the sin of r. I is incidence angle and r is the angle of refraction, is equal to refractive index of second medium with respect to first medium. Second medium is in which incidence ray travels and refracted ray travels, and first medium is in which incident ray travels. The third formula is for mirrors, which is known as mirror formula. This is given by 1 upon f is equal to 1 upon u plus 1 upon v. F is the focal length of any mirror, u is distance of object from the mirror, v is the distance of image from the mirror. And now the next is the for convex mirror, F is positive, U is negative, and V is positive. This is for the convex mirror. And for concave mirror, F is negative, U is negative, and V is negative for the most of the cases. This we have to remember. Next is the magnification power, which is denoted by m. For mirror, it is given by the ratio of size of image to the size of object. This is equal to minus v upon u. This is also equal to f minus v upon f, or f upon f minus u. This is the magnification for mirrors. Next is for the lenses, the lens formula. This is 1 upon f is equal to 1 upon v minus 1 upon u. This is the lens formula. And for similarly for convex lens, f is positive, u negative, and v is positive. For concave mirror, concave lens, f is negative, u negative, v is also negative. Now the next is the magnification for lenses. M is equal to I upon O. This is equal to V upon U. Ratio of V upon U is the magnification. This is also equal to F minus V upon F, or F upon F minus U. So these are some formula for the magnification of lenses. Next is the power of lens. Power of lens is denoted by P. Power in diopter, diopter is a unit of power, is given by 1 upon focal length in meter. Focal length is taken in meters. If we take it in centimeter, then the formula is 100 upon F in centimeter. So this is the formula of the power of any lens. For convex lens, power is positive, and for concave it is negative. Next is for combination of two lenses, suppose we have two lenses, concave lenses, convex lenses, separated by a distance d. Power of first lens is P1 and that of second is P2. Then the total power is given by P1 plus P2 minus dP1 P2, and focal length is 1 upon F is equal to 1 upon F1 plus 1 upon F2 minus d upon F1 into F2. So this is the power for the combination of lenses. Next is the total internal reflection. For total internal reflection, sine of critical angle is equal to 1 of refractive index for the denser medium to the rarer medium. This is the for total internal reflection. Next is for diffraction. For diffraction, the formula is A plus B n into lambda, sin theta is equal to n into lambda. A plus B is the number of lines per centimeter in a diffraction grating. Theta is angle of diffraction, n is order of diffraction, and lambda is the wavelength of light used. Next is the simple microscope. For simple microscope, magnification power is given by 1 plus d upon f, where f is the focal length of the lens, convex lens used in the simple microscope, and d is the least distance of distinct vision, which is equal to 25 centimeter. Next is for the compound microscope. For For compound microscope, the magnification is equal to V upon U one plus D upon F. This is the formula for the magnification of a compound microscope. Fe, this is the focal length of the eyepiece. This is also equal to L upon Fo 1 plus D upon Fe. So there are two formula for the magnification. And next is the astronomical telescope. For astronomical telescope, magnification is given by F upon Fe. So these are a few formula on which we will discuss the numericals. First numerical is the of refractive index. Let we have a refractive index of glass is 1.5. Find the velocity of light in glass. The answer is the refractive index is 1 upon 1.5 for the glass. This is given by C upon V. C is the velocity of light in vacuum divided by V is the velocity of light in glass. C is equal to 3 into 10 raised to power 8 and divided by V. So V is given by 3 into 10 raised to power 8 divided by 1.5, which comes out to be equal to 2 into 10 raised to power 8 meter per second. Now the next numerical is the refractive index of glass with respect to air is 3 upon 2. Find the refractive index of air with respect to glass. Yes, so in this case we are given the refractive index of glass with respect to air, which is equal to 3 upon 2. Now we have to find the refractive index of air with respect to glass, which is the reciprocal of refractive index of glass with respect to air. So this comes out to be equal to 1 upon 3 by 2. It is equal to 2 by 3. So this is the answer. Now next is the third question. Find the distance of the image formed from the mirror if object is placed at focus of convex mirror of focal length 20 centimeter, Now in this case we are given a convex mirror whose focal length is always taken as positive and it is equal to 20 centimeter. Now the object is placed at the focus, so distance of object from the lens is u, which is taken as negative, minus 20 centimeter, and we have to find the distance of image formed. Now applying the mirror formula, 1 upon f is equal to 1 upon u plus 1 upon v. So this implies that 1 upon v is equal to 1 upon f minus 1 upon u. 1 upon f is equal to 20 minus 1 upon minus 20. So this comes out to equal to 1 upon v is equal to 1 upon 10 and v is equal to 10 centimeter. So this is the final answer. Now the next question is, a lamp is placed between two plane mirrors inclined to each other at 30 degree. Now we have to find the number of images formed. We have to find the total number of images formed. Now the answer is, the formula for the number of images formed between two plane mirrors is 360 degree divided by theta minus 1. Theta is the angle between the two plane mirrors. In this case, theta is given as 30 degree. So putting the values, 360 divided by 30 is 12 minus 1, it comes out to equal to 11. So total number of images formed is 11. Now the next question. A candle is placed at a distance of 15 centimeter from a concave mirror of radius of curvature 30 centimeter, find the distance of image of candle. So this is the question and the answer is, in this case the radius of curvature of concave mirror is equal to minus 30 centimeter, because for concave mirror radius of curvature is negative. So the focal length is equal to r upon 2 is equal to minus 15 centimeter, and object distance of object from the concave mirror u is equal to minus 15 centimeter. Now we have to find the distance of image formed v. 1 upon v is equal to 1 upon f minus 1 upon u, which is given by minus 1 upon 15 minus 1 upon 15. Negative becomes a positive. Minus 1 upon 15 plus 1 upon 15. It cancels out. It is equal to 0. So 1 upon v is equal to 0 and v comes out to be equal to infinity. So final image is formed at infinity. Now the next question is, a concave mirror has focal length 50 centimeter. How will you place the object in front of it to get it magnified two times? So in this case we have a concave mirror whose focal length is 50 centimeter and it is taken as negative because the mirror is concave. Now the magnification m is equal to v upon u is given as 2 because the image gets magnified by 2 times. So we have v is equal to 2u. Now 1 upon f is equal to 1 upon u plus 1 upon v. This is equal to 1 upon u plus 1 upon 2u. It comes out to be equal to 3 upon 2u, and u is equal to 2f upon 3. This is equal to 2 into, this comes out to be equal to 3f upon 2 and it comes out to be equal to minus 75 centimeter. The answer is minus 75. Now the next is if a water tank of 2.6 meter depth is filled with water by how much does the bottom of tank appears to be raised. The refractive index of water is 1.33. So in this question, the refractive index is equal to 1.33. Refractive index is 1.33. Real depth is 2.6 meter. Now we know that mu is equal to real depth upon apparent depth. We have to find the apparent depth. Apparent depth is equal to real depth upon refractive index mu, which comes out to be equal to 2.6 divided by 1.3. It is equal to 2. Now the apparent depth is 2 meter. So the bottom appears to be raised by distance d, which is equal to real depth minus apparent depth. It is equal to 2.6 minus 2. It comes out to be equal to 0.6 meter. So bottom appears to be lifted by a distance of 0.6 meter. Now the next question is find the magnification produced by a concave mirror of focal length 20 centimeter when object is placed 25 centimeter in front of it. Now in this case, the distance of object u is equal to minus 25 centimeter, because u is always taken as negative, and for concave mirror f is equal to minus 25. centimeter. Now firstly the magnification power is given as f upon f minus u, putting the values minus 25 minus 20